Okay, so let's find the inverse of our next function. We have f of x is equal to the 7th root of x minus 3 plus 6. And then we're asked to find the domain and range of both functions. So let's start by finding the inverse. Remember, first step, replace f of x with y. So y is equal to the 7th root of x minus 3 plus 6. Second step is where we flip x and y. So instead of y equals, we have x equals the 7th root. Instead of x minus 3, we're going to have y minus 3 plus 6. And we need to solve for y. Okay. So first thing we need to do is subtract that 6 from both sides. And I'm going to rewrite my radical on the left-hand side, just because most students are more comfortable when the variable for which we are trying to solve is on the left-hand side. Okay, so we subtracted the 6 from both sides because we had the plus 6 going on. So I subtracted that 6. And now we need to get rid of this 7th root. Remember when we had a square root, we squared both sides of the equation. If we had a square, we took a square root. Here, because we have a 7th root, we are going to take both sides to the 7th power. So on the left-hand side, we're going to have the 7th root of y minus 3 to the 7th power. Now on the right-hand side, we'll have x minus 6 to the 7th power. On the left-hand side, the 7th root and the 7 are going to cancel each other out or undo each other. So we get y minus 3 is equal to x minus 6 to the 7th. You cannot distribute that 7 because we have subtraction inside the parentheses. And we still need to get the y by itself. Keep in mind, we're solving this entire equation for y. So we need to add 3 to both sides of our equation. We get y is equal to x minus 6 to the 7th plus 3. And then our last step, we need to replace that y with the inverse notation. Remember, inverses are unique. There is only one inverse for every function if the inverse exists. And without that inverse notation, in this case, the f to the negative 1 of x, people would not know that this inverse belongs with our f of x function. Next, we need to find the domain and range of both functions. To keep this organized, students typically like when I use a table. So I'm going to have domain and range be my rows. And then my columns will be f of x, my original, and f inverse of x. All right. So if we look at our original function, this is a radical function because we have that root going on. And this time our index is 7, that itty bitty little number. Right there is 7. And we know that 7 is odd. With our odd index radicals, the domain is immediately all real numbers, negative infinity to positive infinity. When you have an odd index radical, we know that it's automatically going to be all real numbers, negative infinity and positive infinity, because we can plug in anything we want into our function, and we wind up getting a nice number, a real number. Nice may have been an overstatement, but we can get negatives. So, for instance, if we took the fifth root of negative 32, we could get negative 2. And we could just keep going with the seventh root. And if we really wanted to, the 11th root. Anything we wanted to plug in, it's okay because we will get an answer out that's real. And that also means when we're looking at our range, we're going to wind up hitting all the negatives and all the positives, which means that I'm going to have negative infinity and positive infinity for my range of my original, which is also the domain of the inverse. Otherwise, if I look at the inverse, I have a polynomial function. I know, polynomial function, but here it's in a degree. And our leading coefficient is positive, which means it's going to rise on the right, fall on the left, which means that we are going to hit all the negative values and all the positive values, regardless of what's going on in here. Okay? So remembering our polynomials also helps out because we need it for our domain and range when we're talking about our inverses. So don't forget everything you've already learned.